Hi, this is Chong Kim. Welcome to Ruby Chess, version 3, part 4. Okay, so let's get started. All right, it looks like we have a debugging statement there, so let's just get rid of that. Okay, see if it passes. Okay, it passes. All right, so let's, just to speed things along, I'm going to create X context. And that takes arguments and it'll do nothing. This way I can easily comment out a good section of code here, so I'll just comment this out so it'll just run a little bit faster. All right, so we have a way of getting possible moves, but one thing that we're missing is determining the end of the game. So let's create Checkmate. All right, so let's get a position here. So we have a king on e1, a king, lowercase k, on e3, and a black queen on e2. So this is a checkmate position. So checkmate. This should be okay. So white is in checkmate. Okay, and we'll swap this around, and we'll say the turn is black, and that's also checkmate. What's not a checkmate is if I don't have a queen over here, and that should be false. Okay, so we have false and checkmate for white and checkmate for black. Okay, so let's write checkmate. Okay, so let's write checkmate here. All right, so it's checkmate if you're in check and the possible moves are empty. All right. So, all right, so let's take a look at the possible moves. Okay, I just want to print this out. Okay. So it looks like the first one passed, but the second one here looks like it was trying to castle. So there's a problem with the way it's not, it can't castle if it's in check. So let's add that as a rule. See, that should be under, oops. Okay, so let's go to move piece, and this section of code here is about king castling. So the piece is a king, and you're trying to move 2 squares. You're not allowed to castle if that option is taken out, but also we'll add this thing if you're in check. Also, if we'll make a move here, dupe move okay, so we'll move from actually the from to right in between. So from plus 2 divided by 2. This is between the from and 2, so this is along the path. And let's see. So this matches with that. We get that. Okay. So it's in check or temp in check. Okay. So this is saying you can't be in check and you can't go through check. Okay, no method and okay. It's supposed to be and. Okay. All right, so let's get rid of that print statement. All right, so that passes. Okay, so the next condition, spec. The next condition is stalemate. Stalemate looks very similar, so I'll just copy this. Okay, except that I'm going to change this to a pawn. And for this, the king has to be on the other side. And this one is on e6, and the white pawn is going to be on e7. It's black's turn and stalemate. Okay, so let's write stalemate. Stalemate should be pretty much the same, except that you're not in check. Not in check and no moves. Okay. I've got an error with this checkmate here. Oh, that's because this should be stalemate. Okay, so everything passes. And there's one other condition, and I'm going to skip the test for this. This is draw. And the reason is because this just checks a variable. Half move. 100. If it's greater than 100 and it's not checkmate, actually we'll just say it's greater than or equal to 100. Okay. All right. So there should be another function called game end, and that happens if it's a checkmate or stalemate or a draw. Okay, so these are the terminating conditions. Okay, so we're ready for the Minimax now. Minimax is an algorithm where where white is trying to maximize his score while black is trying to minimize the score. So you have, and they take turns. So one tries to maximize and the other one tries to minimize. So what we're going to do is write the base cases first. So let's take the case where, actually let's take the checkmate here. We have the two checkmate positions, so let's just copy those. So these are checkmates. So when we call Minimax on this, then for the first one, let's see, white is, actually this isn't the right one. Okay, that's the right one. One for white and one for black. Okay, in this case, white is checkmated. So this should give us negative 100. And in this case, black is checkmated. So this is going to give us 100. Okay, and if we have a draw position, for example, stalemate, actually this is a stalemate, then that's going to be equal to a 0. Okay. All right, so we got checkmate, stalemate, and also for a draw too. Okay, and a draw is where the half move is going, let's put that as 100, well, just 100. And so that's going to be a draw. Okay. All right. All right, so these are the base cases. So let's put this into code. Okay, so we need to create Minimax. Okay, and let's just run it. Okay, so expecting 100, negative 100. Okay, and expecting 100. So we have to determine if it's checkmate. If checkmate, then we're going to return based on white's turn. If it's white's turn, it's negative 100. Otherwise, it is 100. Okay, expected 100 but got true. Checkmate. Oh, I think the test, yeah, I need to change all of these to say Minimax. All right, so the first error, let's see, in this case we have the king. Minimax should equal 0 but got nil. That's because we're not testing for a stalemate or a draw. Okay, so else if stalemate, actually we can just return 0. Let's see, all right, and or a draw. Okay, so we have our base cases. Now we need to create the recursive case, and we can do that by taking one of these checkmates. Okay, so I'll take these two. And in this case, I'm going to make it one move away. So the queen is going to be on d3 over here too. So it's a one move away. And so this should be 99. Okay. It got 0 instead. Okay, it is actually it's one move away, so that means I have to switch turns. This should be black's turn, and this should be white's turn. All right, got nil. All right, so let's handle that situation. So this is the case. This is an else case right here. So else. All right, so we already have the base case, so we can start off with the possible moves. Actually, there's two cases. If turn is white, then we're gonna do this. Else, we're gonna go over here, but it's gonna start out looking the same. Okay, so then we have the move here. All right. So the way the alpha beta works is, okay, we're going to pass in some values here first. Depth is 1. Alpha is going to be set to, normally this is negative infinity, but I'll put negative 999. And beta is going to be 999, positive 999. Okay, so the algorithm is alpha is equal to the maximum between whichever is bigger, the previous value of alpha or the minimax. And for this, we're just going to duplicate and make the move. And okay, this is just a, let's see, MV map to square on this. So MV is just a list with the first element being the from, the second element being the to, and for each of those I'm converting into a square. So that's just the move. So I make the move, and let's see. Then I find the minimax value of it. Okay. Then between these, I get the max. So if the beta is less than or equal to the alpha, then we're going to stop. Because this is what this is saying is that the found a move that is worse than what it was looking for, so it'll just stop. Okay, I refer you to the Wikipedia page on alpha beta pruning. Okay, and at the end of this, we're going to return the alpha. And for this, we're going to actually alpha, but with the penalty, which is the depth. And for this, it'll be very similar, except that we're doing this on beta. and instead of max, we're doing a min. Okay, same test to break out. This time we're going to return the beta plus the depth because it's going the other direction. All right, so let's take a look. All right, so let's see. Argument, wrong number of arguments for which one? Minimax. Okay, no. Which wrong number of arguments? White, 16. 16? 16 and 260. Minimax, 260. Oh, this is supposed to be colon white. Okay, so this is going to run forever because I didn't specify the depth. So I didn't take care of the depth condition. So if the depth is, let's say, greater than 2, we'll just keep it small for now, then return evaluate. And evaluate is going to be, let's see, evaluate the value of the position. And let's evaluate the position by scoring the pieces. So we set the result to be 0, and then we're going to add how many rooks there are, white rooks, and they're worth 5 points. We're going to add, okay, knights, okay, the number of knights times 3, and then we'll do the same thing for bishops, and for the queen, let's make that worth 9. Okay, so we have this. Make a copy of it so that we do this for the black pieces. So we subtract those values. Okay, so that's evaluate. All right, let's see. It's still taking quite a bit of time. Oh, the reason why is because, okay, the reason why is because we're calling Minimax recursively, but we didn't send the parameters. The depth is going to be 1 more. Alpha and beta is being passed along. Okay. Right. And this is the same. Okay. So let's see now. Okay. So this didn't work the way we expected. So let's see what's going on. Expected 99, but got -8. Okay. Possible moves. All right, so for the depth, oh, greater than or equal to 2. Right, so let's just make this greater than 2. Okay, so everything passes. We didn't set the depth far enough. Okay, so let's just make, well, okay, we'll just, actually, let's make it depth 3. See how long this takes. Okay, so it's, actually the position doesn't call for it. The position is, has a mate situation here, so it's pretty quick. Okay, so we have Minimax, and next thing we need to do is define best move. After we define best move, then we're able to actually play with the computer. All right, so actually let's get the checkmate situation here. Okay, 1 move away. Okay, and I'm gonna call for the best move. And for this, I'm expecting the best move would be from d3 to e2, because that would be checkmate. And this one, same thing. The best move, this is black's turn. Best move is to mate, and white's turn. Okay, so we need undefined method best move. So let's go make best move. Start with the possible moves, and we can just get the we're going to send, if it's white's turn, then we're going to do max by. If it's black's turn, we're going to do min by. Okay, so, and here it is. So we have the move, and make a copy of our situation, our position, and make the move, which is okay. So this makes the move, and call Minimax on that. All right. So this is going to be based on the Minimax. Okay, so let's just take a look. Okay, it passed. So it took a little bit of time, 5 seconds, but it's not bad. Okay, so now we have okay, so we can just we're pretty much done with the RSpec part of it, because the rest we're going to create a user interface. But actually, there are a few things that we can do to kind of speed this up, and one of the things is to use caching. So if there happens to be, let's see, cache, set that to be an empty hash, and we can put something in here that says if cache inspect, make that into a value. Let's see, maybe call it from cache. Cache value. So if there is a cache value, then we just want to return it. Okay. All right, so, and we also need to set it right before we return. So cache of this is going to be alpha minus depth and alpha plus or beta plus. Okay, actually let's just say beta plus over here, and just for both of these just value. Okay, because I don't like having these repetitions here. Okay, so alpha minus depth. Okay, value. All right. Uninitialized variable cache in position. Okay. Oh, that's because of the Minimax call. So I'll just specify here cache. If it's not set, then set it to be blank. Okay, uninitialized. Oh, I misspelled cache somewhere. Here it is. Another place. Okay, so cache value, there's cache, there's the other place. Well, took off about a second. Okay. All right, so let's go write some code for the game. All right, so now we can change the logic of this. We can say while position game end, we say while it's not the end of game, and depending on the position, turn is white. If it's white's turn, then we'll get the string, and this will be an if, because it may be a sequence to terminate the program, like Control D. All right, so if it is, then we're just going to chomp it and make the move and print it out. See. Okay, so that's okay. So it moves a position, it prints it out. Okay, and then this part is the okay. This is end else. Okay, so this is the part for the computer. Okay, position, move. Okay, so this is getting a sample, but instead we're going to ask for the best move. And it's going to make that best move and print it out. All right. So, all right. So let's. All right. So I'm going to take off that. So now I can just save without it running RSpec. All right. So let's play the game. Actually, make this thing executable and put one of these headers there. So then I could just run it as game. All right. So let's take a look over here. E4. Okay, so I made my E4 move, and I'm waiting for black to make a move. It's probably going to take quite a while because it's going through 2 levels and all possible moves 2 levels deep. So while this is going on, let's take a look at the code to see if we can put some print statements in here to see what's going on. So if it's a cache, let's print out, let's print C for cache. And if it reaches the end of the depth, let's print out a dot. And if it's a checkmate, let's print out a hash for checkmate. Stalemate, we'll just print out a 0. And for the rest of this, we'll just leave it alone. Returning a value here. Okay. Okay. Oh, actually, it made a move. It made the knight move over here. All right. So then I'm going to do bishop c4. Now it's waiting for it to make a move. And see. So this is for the next time. All right. So instead of, well, actually, let's just watch it play from here. This is taking quite a bit of time, though. We could run this through the Ruby profiler and see where it's being slow and optimize it. But right now, we basically have the structure of how to write a chess program and how to make it think. Yeah, it doesn't think very well because it's only going down 2 levels deep, and the evaluation is not that good. But this is something that you can play with. You can fool around with. Instead of using Minimax, you could use a different algorithm, like the A-star algorithm. You can see it still haven't made a move yet. Let's see, you could find other ways to make things go faster. You can even try to use a different data structure. Also, Ruby is not known to be fast, so for this, it'd be interesting to see what would happen if I wrote this in C, but probably not. Okay, I'm gonna terminate this. Oh, actually, just made the move. So what I'm gonna do is I'm gonna at the end of the best. Okay, here's best move. I'm gonna have node count. Set that equal to 0. And when it gets called over here, okay, node count. Okay, reset it to 0. Okay, so if all right, so if I'm going to put another condition here. So if node count reaches a certain level, let's say 100 for now, then we're going to return alpha depending on whose turn it is. So if it's white, we'll just return alpha. Actually, -999. Otherwise, we're going to return 999. Okay. So this way, basically saying that anything after the 100th node, it won't count. All right. So this is just going to be fast, but let's take a look. Got these error messages. All right. So let's just see. Okay. E4. Oh, I see. One thing I forgot to do is increment the count. So node count is 0, but okay, so for the cache depth, evaluate here. So I'll just node count increment it here. I don't really, let's see, checkmate is, actually I'm going to do it this way because I wanted to increment the node count here like this, and so it'll always increment the node count. All right, so let's take a look. Try again. Okay, E4. Okay, so it just looked through 100 nodes. It's a very small sample. Let's see. Actually, what would be also interesting is if print an X here, if it is, we'll see how many nodes it skipped. Okay, so E4. Okay, so this is probably gives you an idea of how many possible moves that it skipped, and we don't know which level these are, but we know like it skipped a whole bunch of moves. All right, so okay, so let's do D4. Okay. Okay, so far so good. So let's write the user interface for this, a better user interface. So let's go to the game and require Gosu. All right, and see, class, we'll call this, well, this is game, so, and we'll call this, I mean, this is the Gosu window. All right, So for the initialization, let's set the width. Width, and actually we'll just call it width, and the C width is, okay, width and C width. Okay, so at width is equal to C width times 8, and C width, this is the cell width, it's going to be 100, and the height, actually the height is going to be the same as the width. All right, so call super with width. Okay, so width, and false. False is whether or not we want full screen. Okay, and all right, so we have this code over here. Oh yes, position. So we want a new position, so we have a position there now. We don't need to print it out. And let me see, if the game ends, then if the game ends, then what should we do? Actually, let's worry about that later. Okay. All right. So actually, we can just get rid of this because there's not a lot of logic in here. So okay. And let's start the game. So game is equal to game new game show. Okay. Save it and we run it. So right, so we have our little thing. So, and we have a few problems, which is a mouse cursor disappears when we go into it, and the only way to close the window is to kill it. So we'll just make those modifications. So button down. So if the ID is the keyboard, Gosu, keyboard Q, then we want to close. Close if. Okay. And we also need to say needs cursor is true. All right, so let's run this. All right, so now and then I type Q and it goes away. All right, so now let's, okay, let's draw some stuff. Okay, we want to draw a rectangle, so draw quad starting from 0, 0, and the color, we haven't specified the color yet, 0 C width, color, C width, color, and C width 0. Am I doing this right? Yeah, color. Okay, and we specify the color as, let's set it as, let's put a dark color. Okay, and we'll specify the dark here. So dark is going to be, Gosu color alpha RGB. So the alpha is set to full blast, so so it's not transparent. Okay, so it's going to be a dark color, so we're going to stay low. So OX20, okay, OX20, and all right. So let's see what this looks like. So when I'm going to make it so that when I save, it will run game RB. Okay, so it exited pretty quickly there. Let's see what's going on. Okay, undefined local variable color. Oh, right. Oh, it's supposed to be equal. Okay, so we have a dark color here like that. Actually, that dark color, let's turn that into a light color. Actually, dark color RG. So let's turn this D. Okay, so a little bit of a green square. Let's make this a little bit darker green. So bring this down a little bit, bring to an A. Okay, maybe a little bit even darker. So put this to an 8. Okay, so we have a dark square. So now let's see what a light square would look like. At light, Gosu color. Okay, so let's create a color for that one, which is, it's going to be light. So we could make it all white, but we have white pieces, so it's going to be hard to see the white pieces. So instead, we'll do a little bit off-white. So let's do AO, AO, and this one a little bit less. So 8O. Okay, and let's just see what the light color looks like. Okay, that's not bad. All right, so let's alternate. So let's go from let's see, 0 through 8, 0 through 7 actually, and okay, this would be an I, and then we'll go from 0 through 7 again, and J, and translate I times 100, or C width, and J times C width. So everything inside of this will be translated to that. So, and the color is going to be depending on I plus J mod 2 equals 0. It's gonna, okay, so it's gonna alternate between light and black. Okay, and we need this formula here. Oops, let's see. All right, so let's see what this looks like. Oh, it broke. So let's see what the error was. Undefined local variable C width. Oh, I spelled it wrong. C width. Invalid null reference of type color in draw. Color, color, color. There's color. C width. All right, let's look at this. Draw invalid null reference of type Gosu color argument error. Null. Color is equal to, oh, I said black. That should be dark. Okay, so our chessboard doesn't look so bad. Okay, so now let's put some pieces there. All right, so this draws, let me see, this matches with this one, and this matches with that one. Okay, so actually, along with this, right after this, we can actually, if we had a font, so we'll create the font here. So font is equal to Gosu font new, let's see, takes a window. The second argument is the name of the font. So Gosu default font name, and the size we'll see is C width. Okay. All right, so we have the font, and then we can say we can draw the text. For now, let's just put the piece in there. So position, the index is, see, I plus J times 8. Okay, so index. And we need the X and Y position, which is going to be I times C width and J times C width. And the Z index, it's not layered or anything, so we'll just put 1. X and Y scaling, and the color. This is the important part. So this I'll just say black for now, and black will specify right here. So black is color, and we'll just say black. And I think there should be white as well, so white. Okay, so let's take a look. Okay, what's the error here? On position. Oh, that's because it is at position. Okay, close. All right. Oh, the reason why is because we're inside of this translate. So we don't need to specify the I and j at all. So we can just say 0, 0. All right, so let's see. All right, this looks good. All right. So let's translate those into the pictures of the pieces. So let's say pieces is equal to the set rook, knight, bishop, queen, king, pawn. Rook, knight, bishop, queen, king, pawn. Okay, so let me just, okay, rook is, it's a, actually let's just do it for, okay, the rook. Okay, knight, bishop, queen, king, and pawn. Okay, actually I'm not going to do it for the other pieces. It's just going to be this. I forgot a quote here somewhere, this one. All right. Okay, so see, upcase. So in this case, I'll just look it up under pieces. Otherwise, it's just an empty string. And depending on what color it is, so actually, piece is equal to position IDX. Okay, so this is piece. And then we upcase it. And so we look at the color of the piece. Piece color is black. Then we use black, otherwise white. Error. So let's see, what's the error? Undefined local variable position. Oh, again, position. It's at position. Looks very nice. Okay. All right, so now I'm going to be able to click and drag the piece. So let's do that. That's, I gotta quit out. Okay, so to do that, we're going to okay, we have button down here, and we're going to set the from is equal to mouse, the X position, divided by the C width, and actually the mouse X is going to return a floating point, so we need to say 2i to this. And then mouse Y, convert that to an integer, divided by C width, but multiply it by 8. Okay, so we have that. If Gosu mouse left button. So if I press down the left mouse button, then I have the from. And then I have button up. Okay, so for button up, the 2, okay, so if the button up is the Gosu ms left, then the 2 is going to be, see, this. Okay, so we need to make the move to the position. So position, so it's at position, move, okay, from to square to square. Okay, so we're going to make the move. Okay, so let's see if this works. Okay, so I'm going to drag this here, and that threw an error. So let's see what the error was. Undefined local variable from. Okay, right. Because it's not from, it is at from. Okay, so let's try this again. Okay, so we're able to make a move. And I should be able to make a move for black now. So I'm able to, if I try to see if I can make some illegal moves. Okay, so it's black's turn. So if I try to move my white knight, I still am able to move my white knight though. This is okay. All right. So there's something wrong with see, position, index. This is to draw, move up, and you make the move. So let's take a look at move here. Okay, so when you're doing the move piece to and from, and you switch the turn. So is there a check in here at all? Okay, so here it is. And actually, there's no check in here to make sure that the moving is legal. So okay, return. Let's see, I'm going to say return nil if move piece from to, and we'll say it's false. See, move piece. Okay. Is nil. Okay. So now if I try to move, oh, it still allows me. Let's see, is it legal moves though? Let's see, if I move my queen like a knight, it won't let me move my queen like a knight. So it has to be legal moves, but it's not checking for whose turn it is. So let's take a look at move piece, and move piece from to. Okay. All right. So in this case, let's put a check in there under move. So we have a from piece. Okay. We'll put an extra condition here saying that or. Okay, so this is saying it's legal or illegal, or the from, the piece color must equal the turn. Okay, so now it's white's turn, and I'm not able to move here. Okay. Interesting. Let's put a debugger over here. All right, so let's take a look at piece. It's a pawn. Turn. It's white. Piece dot color. Oh, I said it is equal. Okay, so the logic is wrong. It's supposed to be if it's not equal to the turn. Okay, so that makes it better. All right. Okay, let's get rid of the debugger. Okay. Okay, I probably have a bunch of these. Let me just quit out of these. Okay, I guess I don't. All right. All right, so I'm able to move, and if I try to move this one, okay, now it's not. Okay, so I'm alternating turns now. Okay, so this is okay. Better interface. All right, so next, I'm going to have the computer move after I move. So let's go back to the game and button up. Button up the see the okay. So the move, draw, and see. I'm trying to think where I should put it, because if I put it right here, right after, then it doesn't get a chance to draw. And so if it takes like 1 minute, then you won't be able to see your move until 1 minute later. So I suppose I can do it here in the draw, so that after it drew it. Okay, so I'll do it. There's also update. So let me just put it on update. Okay, so in update, if position turn is black and position game end, okay, not, and it's not the end of the game, then let's make the computer make the move. So position best move okay, so at position dot move. You know, this has been kind of bothering me, so let me just go into the move over here. Okay, and change this to args. And if args count size is 1, then else stir is equal to and for each of those let's see, to square. And okay, so we set the string over here. Okay. All right. It's probably because the code over here is not done. Let's take a look at move. Okay, so now we should be able to just say from 2. Take all this out, so it's getting hard to read. Alright, so let's take a look at move. Best move, move, okay. Position, move, MV. Actually, we could have just done did it this way. Alright, so this makes the move. Okay, so it's not going to be playing a great game, but oh, undefined. Okay, that went away too quickly. Let's see what the error is. Move, undefined method match for B8 to A6. Oh, interesting. Oh, because that was a okay, so let's see where the I had this wrong. This is a list, and well, this should have worked. Stir, match. Okay, so oh, okay, that's because stir. Okay, let's see. Move, undefined method match for array, no method error in 210. So 210. Interesting. It's not where I expected. Oh, it thought it was an array of something. Match, stir. Huh. Interesting. Interesting because it thinks that string was an array. So I'm going to put a debugger over here and see what's going on. And I was in the middle of doing something here, but see what's going on here. Okay. All right, so let's take a look at args. That's an array, just as I thought. And if I do this, dash s percent args map e2 square, what do I get? I get a string, which is what I expected. And get the list, tries to do the match, and it should not match. That's correct. Oh, it matched this part. Well, that's correct. Stir. E2 to E4. Okay, so that looks good. I think the reason why is because of the best move. So best move B8 to A6. Oh, I see why. Right. Okay, so in the game, in the update, here's okay, best move should have been passed. Okay. This shouldn't have made a difference, but let's see if this makes a difference if I do it this way. Okay, continue. Undefined method match. Okay, that's interesting. I'm gonna put a debugger over here and get rid of the other debugger. Where's the other debugger? Okay. Okay, so the debugger is probably over here. Okay, I don't need it over here. Okay, save this one. Okay, so let's see what's going on here. Best move inside of best move. Let's take a look at 316. Possible move, send, min-max, dupe, move. Ah, I see. Okay, because we got rid of this, so now it's just going to be this way. All right. Okay. Undefined. Okay, so it's all with the new move. Okay, move. Okay, so let's take a look at all the places where I'm calling move. Probably not a good search term, but let's see here. Move piece. Okay. All right, so here's another place, so we can just get rid of this, and it's just this now. Okay, I think we got it all. Nope. See what it's complaining about. Dupe, move, Minimax. Okay, so it's with Minimax, there's an extra parentheses. Too many parentheses over here. Okay, so let's see. Oh, got caught on the debugger. And let's just quit out, get rid of the debugger. And get rid of that. Try again. Oh, all right, so we have a game now. Bring this knight out. See all these dots where it's thinking? Oh, it made a move. Okay, so here we have made a pretty silly move over there. So here we have a chess game, and this has been Ruby Chess. So I hope you enjoyed this.